Hey there, welcome to another video. Now, with all that you have learned, this video should actually be pretty understandable. Almost, I don't know, easier-ish, I'm not sure. But for some of you, yeah, probably. Because you've learned so much about how to find the slope, and you know how to do that with the slope formula. And because you've learned so much about how you plug in one point and the slope to find the equation of a line, we're just going to put those two ideas together. Basically, that's it. So here's the recap of everything you need to know about how to find the equation of a line. Number one, there's two things you need. You need a point, and it will always be given to you, and you need the slope. Now, we talked about two ways to find the slope. Either it's given, or you can find it from another equation and a reference word, like parallel or perpendicular. The third way you can find it is in this video. So we need a point, and we need the slope. Given to you, you find it from an equation and using parallel or perpendicular, or you find it between 2 points. That's the last little bit. So this puts the idea of, hey, you gotta know the slope formula with, hey, once you find it, you gotta point the slope. That's kind of cool. Now, before we get going on it, need a point for here, need a slope for here. That's why you need the two of them. One note, when you're picking x1, y1, you have a choice. Because we're given 2 points, it does not matter. I always get asked this, well, I picked a different point, I got the same answer. You're right, genius. But listen, you don't need both of them. Well, you need both of them. It doesn't matter which point you pick for x1, y1, or x2, y2. Does not matter at all. We kind of learned that in the slope formula, and we're going to learn it here too. No matter what, you're going to be right, but there are some better options. When available, when you can, pick your x1, y1 to have zeros. That trumps anything else. So we want x1, y1 to have zeros. If we have a point that has zeros in it, that is your x1, y1. If you don't have any zeros, pick the point that has less negatives to be x1, y1. Negatives throw people off because we're subtracting x1 and subtracting y1. Subtracting negatives is harder. Also, we use that twice, so avoiding negatives is beneficial. So again, if you can choose, pick the point with zeros to be x1, y1, and if that's not an option, pick the point with less negatives to be x1, y1. If those don't work, it doesn't matter. Then pick any point that you want, and it does not matter. Let's try that. So let's go through the whole thing. Let's find the equation of a line containing these 2 points. Again, hey, there's 2 things you need. 1 point and the slope. I've got a point. In fact, I have 2 points, but I don't have the slope. This is where your ability to use the slope formula comes in. You can't get around this in order to find the equation of a line. You have to have the slope. So we have 2 points. We need to find the slope. So I'm looking down here. Now I'm going to try to find the point that has zeros. Neither of them do, but that point has fewer negatives. That's the one that I'm going to be calling x1, y1. Does it matter? Not really, but it's going to help you. That means that this point is x2, y2. If I need 1 point and the slope, I've already got 1 point, but I can easily find the slope. We've done it many times. Let's find it. So let's set up the slope formula. I know that we do y2 minus y1 over x2 minus x1, or put this point first, xy, got it. Subtract, put this point second, xy. I'm always going to use parentheses, always, because if these are negative numbers, well, we're subtracting a negative, it would house the negative, it would maintain the operation. Now, this is one reason why I told you to pick x1, y1 to be the one with less negatives, so you're not subtracting negatives. It's just a common mistake people make. So let's double check. I've got x's on the bottom, I've got y's on the top. I've created 1 point, x1, y1, I've created x2, y2, created another 1, 2, 5, so I know that we're right. Now, let's go slowly through it. Make sure that we're not making mistakes. Negative 7 minus 5, it's negative 12. Negative 1 minus 2, that's negative 3. I don't need to leave this in fraction form, but I do need to simplify the fraction. So negative 12 divided by negative 3. Negative over negatives are positive. That's 4. I don't need 4 over 1. You need that when you're graphing, but for the equation, you don't need that. But now, this is pretty cool. I remember that I need a point and a slope. I have more than enough points. I've used it to find the slope. Now we have a point. Now we have the slope. And since I've already identified what x1, y1 is, I'm practically done. Now we can take that point that I have, the slope that I found, and fill out point slope. So that's exactly why we needed to find the slope in the first place, was to fill that out. So let's do it. Remember that when we're filling out formulas, we want to create some blank spaces. We want to not plug in for things we're not supposed to plug in for, like x and y. When we do plug in for the fixed point x1, y1, we want to make sure we put that in parentheses. We want to make sure we're double checking. So x1, y1, well, y1 is 5, y's go next to y's. x1 is 2, x's go next to x's. And our slope that we found, that's when we're going to use it. It's just 4. I hope you're seeing why we like to choose points with zeros if we can, but definitely with less negatives, because we get to use it twice, once in the slope formula and again in the point slope. Having less negatives really helps with errors. I'm trying to avoid errors for you. So y minus 5, no problem. X minus 2, let's simplify that to remove that parentheses that really we don't need. After that, we'll distribute. Hopefully you're getting really good at distribution. We're not missing that second term. Even if we got fractions, we can do it. And lastly, we're going to solve for y. That's nice. That's an equation we can work with. We can graph it easily, and we're going to double check. That has the same slope that I found. That's awesome. And you know what? I can triple check if I wanted to. We can plug that point in. It's got to work. So let's plug in 2. It better give us 5. Plug in 2 here. 4 times 2, that's 8. 8 minus 3 is 5. I know that I'm rock solid on that one. But also, that point has to work. You see, that equation has to contain both points. Man, you can really check your work here. Plug in negative 1. It better give us negative 7. 4 times negative 1, that's negative 4, minus 3 is negative 7, so I am guaranteed that I have the right equation there. That's awesome. No guesswork, know that we're done. The next one, same exact thing. I would encourage you to go through it on your own right now. When we started, there's no zeros in either point, so I don't get a good choice there. They both have the same number of negatives, so either way, it does not matter which point you choose for which. Why don't you try it one way? I'm going to be picking this one for x1, y1. If you want to follow along with me, that's what I'm going to be doing in about 5 seconds. So as we're going through it, my logic is I'm forced to find the equation of a line. I know that I need 2 things, a point and a slope. Points are always given. I have 2 points. So I'm picking one of them with less negatives. That doesn't really matter here. I need to be given the slope. I'm not. Or I need to be able to find it from an equation. I don't have one. Or I need to be given 2 points. Oh, that's it. So if I'm given 2 points, I can set up y2 minus y1 over x2 minus x1. You'll notice immediately I'm not even plugging in a second set of numbers. I'm making sure this is 1 point. X, y, y2, y1. So y2, x2, I have that. I'm putting minuses, and I'm making sure I have parentheses to house any negatives I might get. I'm going to triple check. So this is 1 point, negative 2, 5. Got it. This is another point, 1, negative 4. I know that I'm in order. And now I'm going to find my slope. Five minus negative 4. So we're thinking carefully on that. That's addition. That's 9. Over negative 2 minus 1, that's negative 3. We do need to simplify. Positive divided by negatives and negative. We're going to get negative 3. Now I reevaluate. I need to be given a point and a slope. I was given at least 1 point. I now found the slope. Now I go straight to point slope. These examples don't have to take a long time. You can totally do this quickly and get it right, and that's awesome. Don't rush. but just the nature of understanding this is going to let you move a little quicker. So I'm going to set up y minus y1. I'm going to set up x minus x1 in parentheses. I've chosen this to be my x1, y1. Now, I always get asked this question. What if you use x1, y1 for your slope formula? Can you switch points and use this in your point slope formula? Yes, absolutely. It does not matter. So if you want to switch points around, cool. It really doesn't matter. I'm not going to because I like my choice. We just have to make sure we put our y coordinate next to our y, our slope where our slope goes, our x coordinate next to our x, and not make mistakes on signs. Y minus negative 4. Well, that's y plus 4. On the right-hand side, x minus 1, no big deal. Let's be real careful. We'll distribute this because we're trying to solve for y. We want to end in slope-intercept form. Let's make sure that negative 3 gets multiplied by the negative 1, giving us negative, negative, positive. I say positive, I write plus 3. Last step, just subtract 4. I would love to be your individual teacher like I'm trying to be here and kind of build in you this, this constant checking of your work. So for instance, when I'm building my slope formula, I'm constantly checking I haven't made a sign error and that I have minuses. When I'm building my point slope, I'm constantly checking my minuses, my parentheses, and that I haven't made sign errors. At the very end, I want to be checking that I have my same slope that I figured out here. I'm always checking that. Secondly, I'm plugging points in. So I'm going to plug in 1 and make sure I get negative 4. Negative 3 times 1 is negative 3 minus 1, that's negative 4. I know I'm right. Check the next one just to be sure. So plug in negative 2, that's positive 6 minus 1 is 5. I'm getting out my 5. Now I know I'm right. It only took me about 15 seconds to do that, and I'm guaranteed a right answer. That's much more valuable than saving 15 seconds that may or may not be useful later and kind of going, I'm pretty sure. Because what if you made a mistake? Those 15 seconds just cost you a right answer if you're not checking that. That's why I'm constantly checking. So here's what I'm going to do now. I'm going to give you 2 examples. I would love it if you try them on your own. Obviously you don't have to, but I'm going to give you a little bit of time as I'm erasing this. I'll put up just 2 more points. As I'm erasing the rest of it, maybe pause the video or try them on your own. So we're just about done. I'm giving you 2 points again. Did you pick out the correct choices already for what should be your x1, y1 and what shouldn't be, what should be your x2, y2? Again, it does not matter, but it will help you if you pick x1, y1 to be the point that has zeros, if applicable. If not, well, then pick the one with less negatives. Here, I like zeros over less negatives personally. That's up to you though. So I know that this is x1, y1 for me, and then I'm going to have x2, y2. I know that I need to be given a point, I already always am, and I need to find a slope. Either it's given, or you find it from another equation with a reference word, parallel or perpendicular, or you use the slope formula, which is what we have here. So we're going to set that up. I always write my y2 minus my x2 minus first. I create some parentheses, and I make sure that my y2 and then my y1 are next to each other. My x2 and then my x1 are next to each other. And I can double check. This should be 1 point, and this should be the other point with minuses between them. That's it. So we have 1 plus 3 over 5. Well, that's 4/5. Looks good to me. Now, let's go ahead, let's take our 1 point that we need. We don't even need this anymore, it's just to find the slope. And let's plug in that point with our slope into point slope. Let's create some parentheses. Let's make sure that our y coordinates are next to our y variables. I've used parentheses because I maintain sign and operation. Let's make sure our slope is in front of our main set of parentheses on the right side. Let's make sure our zero is in there. Oh, that's nice. I love using zero because it's easier to distribute. And if it's over here, you don't have to add or subtract at the end. That's nice. That's why we use zeros. Instead of caring more about negatives, we care more about about having zeros. It's nicer. So we fix our negative, and my subtracting negatives adding. We got 4/5. And then check this out. What's x minus 0? X, you're done. No need to distribute at all. That's why choosing zeros is nice. Also, if you have a 0 on the right-hand side for your constant there, for your x coordinate, you don't need to worry about adding or subtracting to anything over here. You're just going to subtract 3, and that's going to fit at the very end of your equation. That's especially nice if you're adding or subtracting fractions, because you don't have to add or subtract to anything. Cool. And I'm good. We got a slope of 4/5. That's exactly what we thought. We got a y-intercept of 0, -3. Could you graph it right now? Always be repeating that in your head. Could you see if you could graph that? 0, -3, go up 4, right 5. You graph the line very quickly. Let's make sure the points work. I better plug in 5 and get out 1. If I plug in 5, denominators are gone. 4 minus 3 is 1. I know I'm right. I plug in 0, I better get -3. Plug in 0, 0 minus 3 is -3. I know for sure that that's the right equation. That's so cool. The last one, yeah, I'd be picking this one for x1, y1 because of that 0. I'm given 2 points. I need to find the slope from those 2 points. So I start with my y2, I subtract, my x2, I subtract. I'm going to make sure that my points are correct. 1 point should be 1, -1, and it is. Other point should be -2, 0, and it is. And I have minuses between them. That's awesome. I'm on the right track. -1 minus 0 is still -1. 1 minus -2, that's 1 plus 2. That's 3. So I have a slope of -1/3. No problem. It's a fraction. Who cares? Let's take our 1 point and our slope. Let's create the point slope from it. If you do that enough, you won't even have to look at a formula. You'll get in the habit of creating parentheses, of having minuses, and not doing any math in your head. It will help you. So let's plug in what we need to. I know that my y-coordinate, there's my y-coordinate. I know that my x-coordinate, there's my x-coordinate, go next to the appropriate variables, and I put my slope back, right where it belongs. So, y minus 0? Well, that's nice. That means that I'm not going to have to deal with adding or subtracting. That's cool. On the right-hand side, I'm going to take a moment. I'm going to fix this minus and negative because I don't like it. Now, it's true that we're going to have to distribute a fraction onto a number that's not a fraction. It's going to create a fraction for us. But because we chose 0, that means we won't have to add or subtract at the end, which means that once we distribute, we are done. That's nice. It's another reason why we choose zeros. So -1/3 times +1x, it's -1/3 x. -1/3 times +2, okay, that's a negative. So I'm going to write a minus. 1/3 times 2, 1 times 2 is 2/3. Easy to graph? No, decidedly no. You'd have a y-intercept of 0, 2, -2/3. From there you go down 1 and right 3. It'd be fractions the whole way. Is it what we want? Yes, that's the slope-intercept form of this line. And it's going to go through those 2 points. We can prove it. Your slope, okay, that looks good. Let's plug in -2. It better give me 0. So if I plug in -2, well, Negative 1/3 times negative 2, that's positive 2/3. Minus 2/3, 0. I know I'm right. Now we plug in 1, we better get negative 1. If I plug in 1 here, negative 1/3 times 1, that's negative 1/3. Negative 1/3 minus 2/3 is negative 1. So I know that both of those points work. That means that's the equation that contains both of those points. Has the appropriate slope. We can tell this line is negative. Negative slope is going to go down. That's the idea. That's about all that I can teach you here. So to recap the whole entire idea of lines, you need a point, you need a slope. If you have one, you can graph it easily. If you have a point and a slope, you can find the equation very easily. If you aren't given, you're always given a point. If you aren't given a slope, you have another equation, you solve it for y, you find that slope, and you use the reference word, perpendicular or parallel, to find the slope you need. If you're given 2 points, you have 1 point, you use the slope formula to find the slope that you need. And then use point slope and efficiently work your way to finding out y equals your slope-intercept form. I hope that made sense. We are going to be using graphing lines for a long time. So it would really benefit you to make sure that you know how to graph a line from this sort of a formula, from this sort of a function, from this equation. Not this one, but from this. Being able to solve for y is really important. We're going to graph a lot with that. We'll start next video, with how we solve systems of equations. That's kind of cool. And our first way to do that is with graphing. So I'll see you for the next video when we graph and find solutions to systems of linear equations. That's a mouthful. See you next time.